What exactly are sets and hash sets in Java? We'll talk about exactly what these are and how you can use them. And we'll also talk about the situations where sets and hash sets are the perfect solution to your program. As always, my full Java course is available in a link down in the description if you're interested. First, thanks to Mailgun for sponsoring this video. Mailgun is how modern companies work with email. Mailgun is easy to use, has amazing world-class customer support, and simple but powerful APIs that smart developers can use to reach customers at scale so their organizations can grow faster. With their detailed documentation, you can easily integrate email into any application with just a few lines of code. You can send and track transactional and marketing messages, remove invalid emails from your list, or just prevent fake signups in the first place easily. Their team of experts is available 24/7 to help you improve your email deliverability and drive higher conversion rates. With its powerful email API for developers and intuitive email marketing solutions, Mailgun works through the entire email lifecycle from planning all the way to the inbox, and it does that for more than 240 billion emails a year for top companies like Wikipedia, DHL, Toast, Lyft, and Microsoft. Mailgun also has an amazing send time optimization feature, which automatically finds the perfect time to send the email to each and every individual on their list at the exact time that they're most likely to engage. Mailgun truly makes it easier than ever to build connected experiences through email. So thanks again to Mailgun for sponsoring this video. Try Mailgun today for free by using my link, which you can find down in the description, mailgun.com/John. Now let's get right to it. All right, so sets and hash sets. Well, first, just what exactly is a set? Well, a set is one of the things available to you in Java's collections framework, which means that a set is one way that you can group a whole bunch of like objects together and handle them as one unit. So for example, you can add items to a set, you can see if a set contains an item, and you can remove things from the set. And it all works very similarly to how you might use something like an array list in Java. So if you used a list or an array list in Java, then you're in luck. This will be very familiar to you. However, sets do have some subtle differences from lists, and those differences really are important because you'll end up using sets to solve completely different problems than you would want to solve with a list. So first, let's just go about actually creating a set. So let's say we wanted to create a variable that holds like a collection of string names, for example. A set is one way that you can do that. So if you wanted to create a set of strings, you would say set, and then in angle brackets here, you have to tell it what type, what class of things are going to be held as the elements of this set. And here, since we want it to be a set of names, it makes sense to make them strings. And then you can see that it automatically imported java.util.set. So that's the import you'll want for set. And then like any variable, we have to give this a name. Since this will be a set that's supposed to hold names, we'll call it names. So now we've created this names variable for our set. So now we have to initialize it. Now you might think that to instantiate your set, you would just say equals new set, right? I mean, that seems to make sense. It's how you create the vast majority of your other objects in Java. But if you try that, you'll see that you get a compilation error, and it says set is abstract and cannot be initialized. This is a part that can be confusing to a lot of programmers, so let's talk a little bit about what's going on here. The reason we get this error is because a set is an interface and not a normal class. Like if we control click into this set, we can see that it says public interface set, not public class set. And you can't create instances of interfaces. You can only create instances of classes that implement those interfaces. Now that is where hash sets come in. So instead of saying equals new set, instead we'll say equals new hash set. And we'll go ahead and put in our diamond operator here to make the compiler happy. Now if we control click into hash set here and scroll up, we can see that hash set implements the set interface. So basically how it works is the set interface is where Java says any kind of class that wants to be a set has to support all of these kinds of operations and methods, like adding items, removing them, looking them up, etc. It's totally up to each individual kind of set to determine how it wants to implement all of those functionalities behind the scenes. The hash set here is one of those actual set implementations. So you might think, hey, if a hash set is just one implementation of a set in Java, are there any others available to me? And the answer is, of course, Yes, there are. We will talk about those just a little bit, but hash set is the set implementation that you are probably going to use 99+% of the time you ever use a set. So that's definitely going to be the one that we focus on here. All right, so now we've got our shiny new hash sets all declared and initialized. Let's give it a ride and see what we can do with it. Again, if you have used lists before in your Java programs, a lot of this is going to look very familiar, which is great. First, let's go ahead and add some objects to our set. And you do that by calling the add method. So we'll just call names.add. And then we pass into this add method whatever we want to add to our set. This is a set of string names. Let's add a name, Walter. Now what we can do real quick here is go ahead and print out our set just to make sure it's adding this name correctly. And to do that, we can just do system.out.println and print out our names set. Now if we go ahead and run our program, we can see that it prints out the contents of our set, which right now is just one thing, the name Walter. Now let's go ahead and add a few more names to our list. Names.add Jesse, Skylar, Mike, Saul. Let's go ahead and run it again and make sure it now prints out all of these names. And there we go. We have Walter, Mike, Saul, Skylar, and Jesse. Now you might have noticed here that it printed out these names in a very different order than they were added. And that's different from how something like a list operates, which always maintains a certain order. So that's the first of the important differences between lists and hash sets in Java. A list maintains the order that you add the elements to that list, and you can also do various things to sort a list in whichever order that you want. But a hash set has no particular order, so there are absolutely zero guarantees as to what order the objects will be in your set after you add them. Now though, let's talk about the second big difference between lists and sets. Let's say I wanted to add something to this set that already existed in the set. So I'll try and add Walter again. Now if we go ahead and run our code to print out our set again, you can see that Walter exists in the set, but it still only exists once, even though we added it twice. And that is because sets, by design, do not allow duplicates. So if I wanted, I could add Walter to this set just hundreds and hundreds of times. It still only gets added to the set once. So now let's get rid of all these extra Walters. One is quite enough. Next though, to remove things from a set is pretty much exactly the same as removing an object from a list. All you do is call names.remove and then pass in the object that you want to remove from your set. So let's say we wanted to remove Walter. We'll run our program and see that Walter has been removed. However, one thing that you can do with a list that you can't do with a set is remove an item by using its index. But that can be a bit deceiving, and let me show you why. So for example, if you wanted to remove the very first thing from the list, you would just pass in the index 0, because 0 is the first thing in your list. So you might notice we don't get any compilation errors or anything, and we can even go ahead and run it without any errors. However, if we look at this, we can see that nothing at all was removed. We still have all 5 items in our set. Well, what happened is, for a list, there's actually a separate remove method that takes the int index of the element that you want to remove. But for hash sets, that separate remove method that takes an int index doesn't actually exist. And that kind of makes sense, right? Because the elements of a hash set are in no particular order anyway. So if you said, okay, remove the 0th element from my hash set, it's pretty much unpredictable which element of the set it's actually going to remove. So what it's actually doing is just calling the version of the remove method that takes in the actual element that you want to remove from the set. And of course, the element 0 doesn't appear anywhere in our set of strings, so nothing is removed. So even though there are no errors and it might look like it might be working, it's probably not actually doing what you expected at all. Now there are a bunch of other methods available to you on sets as well. For example, you can get the current size of your set just by calling names.size. Now there are 5 things in our list, so when we run it, it should print out 5. You can also use the .contains method, which will return a Boolean true or false, depending on if your set contains the object that you pass in. So if we say, hey, does my set contain Saul? It will say true, it does contain Saul. But if I want to see if it contains Gus, it will return false. There's also a method available called is empty, which will tell you whether or not your set is empty. And right now it will tell me false because my set's not empty. Next, if you just want to get rid of all the elements in your set, you don't need to individually remove them all one by one. Instead, you can just call names.clear. And then if we go ahead and print out our names set one more time, we can see that it now contains 0 elements. It's been cleared. You'll probably pretty often run into some situations where you want to perform some kind of action on all the elements of your set. So you might want to iterate through your set and print them all out, add them all to a file, something like that. There are a few different ways that you can do that with sets. One way is using what's called an enhanced for loop. Now to do that, I can say for, and then I want to loop through each element, each string inside my names set. So here I say, OK, for each string name inside my set of names, I want to do the following. So if I want to just print out each name here, I would just say system.out.println and print the name. So what this should do when I run it is just print out every name in the set on its own line. And we can see that that's exactly what it does. Now, one thing to remember here, though, is that since your hash set is in no particular order at all, it could iterate through your hash set in basically any order. However, if you want to be really, really cool and impress all your super nerdy Java programmer friends, if you know how to use lambdas, you can use a lambda to iterate through your set. Now, I have an entire other video on lambdas, which you can find right here if you haven't seen it. But to just do it real quickly here, let's say I wanted to go through my names set, and for each element in my set, I wanted to print it out. Well, I can just call this for each method on my set, and then just pass in the lambda, the function that I want it to execute for each element of my set. So if I want to just print each element out, I can just say system.out : println. It prints out all 5 elements of my set just the same, but does it in a very impressive one line. Now you can also use names.iterator to give you an iterator object that you can use to iterate through your set. And this iterator will work exactly the same way that it does for lists and other pieces of the Java collections framework. So we'll declare our iterator object. It'll be an iterator of strings because our set is a set of strings. We'll give it a name. Let's call it namesIterator and set that equal to names.iterator. Now to use this to iterate over our set, we will use a while loop. So while namesIterator has a next item, has next. So while there are more things in our set to iterate over, we'll go ahead and print out namesIterator.next. Let's go ahead and get rid of this for each implementation, just to make sure our iterator implementation works how we expect. And there we go. We got Walter, Mike, Saul, Skylar, and Jesse. Looks good. Maybe a big question that you might have is, all right, when would I actually want to use this? Under what programming situation is a set or a hash set in particular useful? Now, the simple answer to that is, well, whenever you want a collection of items and you don't want duplicates in that collection, and you don't particularly care which order that they're in. And of course, that kind of varies depending on your particular programming needs for whatever you're working on. But one area that you'll see sets used a whole lot is for something as simple as removing duplicate items from a list. Let's say you have some list that potentially contains a bunch of duplicates that you want to get rid of. Now you could write some kind of clever program to kind of iterate through that list a whole bunch of times and, comparing each element to every other element to see if it contains a duplicate and remove them so it only contains one of each element when it's finished. But a way, way easier way of doing that is take all the elements of that list and dump them into a set. And since a set cannot contain any duplicates, when it tries to add a duplicate to that set, it just won't happen. And your resulting set will be the same as the list that you started out with, but just with no duplicates. Now let me show you real quick exactly how to do that. Let's say we had some list. How about a list of integers in this case? We'll just call it number list equals new array list. So now let's go ahead and add some things to our number list. So number list.add 1, 2, 3, and now we're going to go ahead and add some duplicates. So we're going to go ahead and add 2 again, and then let's just go ahead and add 1 again. So now if we print out our list, number list, we see that we definitely have some duplicates. We have 1, 2, 3, 2, 1. So now if I want to get rid of all the duplicates from this list, I can just add all those elements to a set. So let's go ahead and create our set. It'll be a set of integers. We'll call it number set equals new hash set. So now what we can call is number set dot add all, and then pass in our number list. So this add all is another one of the really cool methods available to you with sets. That allows you to take basically any collection and add all of its elements to another collection. And that's pretty much it. What we should be able to do is print out our number set, and our resulting set should now have those same numbers, but just with no duplicates. And it does. So the list had 1, 2, 3, 2, 1, but putting all those items into a set automatically and very, very easily removed all the duplicates. So we're just left with 1, 2, 3. And you can do this in an even cooler way if you want. You can see that I'm getting a little warning here that says, hey, add all can be replaced with a parameterized constructor call. And basically what it's saying is, hey, you could do this and say, okay, number set dot add all, and then pass in your list. But instead, what you can do is just pass in the number list to the actual hash set constructor in the first place. And you don't even need to call that add all method. And it turns out that it will do exactly the same thing. Now though, I want to give you just a little bit of insight into why this is called a hash set. So the reason it's called a hash set is because this set implementation actually uses a hash table as its storage mechanism behind the scenes. Now, how a hash table actually works is a bit outside the scope of this video. But what using a hash table does is it allows for extremely fast operations on this set. For most types of elements, if they're constructed properly, that allows for what is called constant time adds, removes, and lookups. So what that actually means is no matter how large your hash table gets, if it's very small or if it's very large, adding another element to that set or removing an element from that set or checking to see if a given element exists in that huge set will always take the same amount of time. It'll take a constant amount of time no matter how big or small your hash set is. Now that's compared to something like a list, where the larger that your list gets, the more expensive each add, remove, and lookup operation on that list is. Now I did mention earlier that there were two other set implementations in Java besides hash set. So let's talk about those a little bit now. One of the other implementations is called a tree set. Now if you end up using a tree set instead of a hash set, all the methods that we already went over work exactly the same way. There's really no difference there. Now what a tree set offers that a hash set doesn't is that the elements that you put into that set will be ordered with what's called their natural ordering. So for example, in our original set, our set of names here, if I implemented that as a tree set instead of a hash set, let's go ahead and run it and then see what the output looks like there. Okay, so if I look at how it's printed, I can see that they're not printed out in the order that I added them to the set, but they are printed out in their natural ordering. In this case, since they're strings, they're printed out in alphabetical order. And that's because behind the scenes, this is using a tree instead of a hash map as its implementation of the set. So as things are added to that tree, they're put into that tree in the correct ordering. Now that seems pretty cool, right? So hey, why would I use a hash set ever if it does, all the same things, but a tree set, I could get some ordering out of it. Why would I ever want to use a hash set? And the answer is that a hash set is way, way faster than a tree set. So you should only use a tree set when you're in a situation that you want a set, but you really care about the ordering of the elements. But if you have no need to maintain that ordering at all, it's way better to use a hash set in your program instead, just because it's so much faster. Now the last set implementation is actually called linked hash set. So what's different about a linked hash set is that it doesn't maintain the natural ordering of the elements, but what it does maintain is the insertion order of your elements. So what that means is if I go ahead and run this, I can see that it prints out these items in the exact same order that they were added to my set. Now, as far as performance goes, a linked hash set is almost as fast as a hash set. It isn't quite as fast as a hash set, but it's way better than a tree set is as far as performance. So still, you should only use a linked hash set if you care about maintaining that insertion ordering. But if you don't care about that, it's still in your best interest to use hash sets. And you'll probably see hash sets used way more often in the real world than you will tree sets or linked hash sets. But it's still good to know that they exist in case you need that kind of functionality for the program that you're working on. If you enjoyed this video or learned something, please let me know by leaving a like. And let me know what other kinds of videos you'd like to see in the future in the comments. As always, really thank you so much for watching. I really do appreciate each and every one of you taking the time out of your day to spend some time with me. So I will see you next time.